we started this exercise and the goal was to create structs, and each struct representing a planet. So we have, except Plutus, because we learned that Plutus is no more a planet, no more considered a planet. So we have Mercury, Venus, Earth, and all the other planets. And then we needed to implement a trait for that planet. Yeah, so for example, we implemented planet, which is our trait, for Earth, for Mercury, for Venus, for Mars, and so on. And then our trait planet is implemented here at the top. And what it does, it provides a function, a method called years during, which is going to calculate the space age on that planet. So how old are you if you just move to that planet? So that was the goal here. Yeah, so in Earth, you have 10 years, but if you, for example, move to Mars, you are going to have 10 multiplied by 1.8. So you are going to be 18 on Mars, right? So that was the goal on that exercise, and you see that all this code is very similar. Yeah, so we repeated impli planet for Mercury, impli planet for Venus, and for all the planets. So we have only few planets. Yeah, so imagine if we want to be covering all the existing planets, because we know that there are more things in the space. So if we want, instead of only planets, we want to get all the stars and calculate things. So this code is going to be very repetitive because things are very similar. So what we did to solve this problem, we created a macro. Yeah, so the macro is this thing. We declare it with macro rules. We give a name for it. And in the body of the macro, we can capture a pattern. Yeah, so we have on the left, we have the pattern. So in this example, we are going to capture the identity. So anything that is an identity for the Rust language syntax, for example, the name of a struct, the name of an enum, the name of a function, that kind of stuff. It's going to be matching this identity pattern here. And then we store it in the name variable. And we do with expression. So any expression in Rust, it's a lot, because in Rust almost everything is expression. There's a lot of things that are expressions. And then anything after this is going to be after the comma, obviously, is going to be captured here. So we can build this pattern match here using all those meta variables. And then once we capture this pattern, we have the block that represents this. And inside this block, what we do is we write Rust code. Yeah, so it's like a template. Yeah, so the body of the macro is a template to generate Rust code. So when we call this for each planet here, this macro is going to be expanded before the compiler actual compile the code. So in a pre-compilation, the macro is going to be expanded, and it's going to generate a struct, and it's going to implement a trait for that struct. Yeah, so we can do this to generate any kind of code in Rust. So you see the difference. Yeah, lot of repetition here, lots of boilerplate. We just turn it into a simple macro that we call planet and pass the arguments or the pattern for that macro. And the macro is awesome because here we can really use anything. Yeah, it can be invalid Rust. So these arguments, these parameters that we pass to the macro, it's not required that this is valid Rust. It can be HTML, it can be Python, it can be Ruby. So you can create the macro to evaluate some language for you. Yeah, so you can create your own domain specific language inside the macro, and then you just have to parse it inside the macro and then generate the proper Rust code. Or if you don't want to generate Rust code, you can maybe use some structure to be generating some FFI like Python creates does, and that kind of stuff. So one of interesting macros is called Helix. usehelix.com is something that I tested before. It's an extension crate. Then you can use this crate Helix in your Rust code. And then every time you want to write Ruby, yeah, so looks how interesting. You can write Ruby, and inside the macro body, you can code Ruby code. Yeah, that's interesting. So why are you going to do that? There's a lot of reasons. You can port some code from Ruby to Rust, and you can do that incrementally. Yeah, you can start doing one by one. And thank you for following Easy8789. Welcome. And then you can compile it, and then you can use it from the Ruby console. Yeah, so this is going to be valid Ruby code. So that's really, really interesting. And yeah, Berg is asking if it's not too performatic. So that's the thing. Looks like it's performatic because at some point, Helix is going to transpile this Ruby code to actual Rust code. I don't have all the details here, but that's what is going to happen. People are using it to create some Ruby gems that are performatic Ruby gems. Yeah. Luis Cassiatori, thanks for following. Rust is a functional programming language. That's the question. Okay. 1 second. I'll just get back to that question. Yeah. So Helix is nice. I remind about something that allows us to use HTML. I've typed HTML. It's something like this. Yeah. So as Nathaniel is saying, it uses procedural macros. But that's interesting because you see it's a macro that you can use inside your Rust code, and then you can pass just HTML code. Yeah. So it's not valid Rust. It's just something that's going to be captured. And then, for example, I imagine that this thing is going to transform it into some template and then render the template later. And then you have Rust compiled and lots of strings that's going to be rendered as a template at the end. But for the developer, it's just HTML written inside Rust. Yeah. So that looks very cool because you can actually use some Rust construction inside the HTML, and you can also use recursive calls. So you can call a macro inside a macro. So it's very powerful. Yeah, some macros before we start implementing our own macros. So there are some macros that are very common to use in Rust. And for example, the first one that everyone is going to use is the print ln and the print. Actually, there are the two, print and print ln. The difference is that print ln is going to put a line break. And here we can print anything like hello world. Let's run it. Okay, our hello world is here. And this can do some interpolation. Yeah, so it can do, you can put some kind of template here, and then you pass here the word that you want to be passed to that template. And if this object here implements the display trait, it's going to be replaced here, and you can print it to the terminal the same way. It can be a variable, and I think it also can be named. I'm not sure about that. Let me test it. I think it can be named. It's on one of the places that this thing can be named, if I'm not wrong. Maybe I'm wrong on this, but let me check. Yeah, it can be named. So, you know, in Rust, functions can't have named arguments, but the println macro can have named arguments here, because as I was talking about, in macro you can capture those patterns and split things there. So one way of having named functions, named arguments, is using macros maybe. So another thing that we can do, for example, if we have, let's create a struct here. I'll put here a name, and this name is going to be a string, just a simple thing just for us to print. And for example, I can just pass an instance of a person here directly, and this person is going to be me to string. Let's remove my... So yeah, now I don't have this name here, obviously. So I will just print the whole thing. And you see an error, right? And this error says that, for example, I can't use this macro with an instance of the person struct, because this struct is not implementing the display trait. So to be able to transpose this template we have here on the println, I needed to implement the display trait for this struct. But we have also debug, so we can use a semicolon and a question mark here, and then this is going to run debug, and then you are going to see that it's also not possible because this object doesn't implement the debug. But the best part is that we can just derive debug. So we can come here and derive the debug trait. I think it's all we need. And then we can just print. So you see that when we print this way, we get the whole object. Yeah, if we want to take only parts of it, then we need to rewrite the implementation of the bug, or in the implementation of display, to take just some parts of the object. Yeah, and then and actually I can also do different. I can create here my instance of person, and then I can pass person name directly. And person name is a string, so I can have a string here. And as person name is a string, I can also do like this. I think, yeah, because a string implements display. Yeah, so the member of the struct implements display and can be showed with this macro. So this is one of the simplest macros you are going to see. And I was used to use println as a debugger. Yeah, just the same way I do with Python sometimes. I always do print just to see how my code is. But recently we got dbg, which stands for debug. So I can just do, for example, this let person equals person. What I can do is like this, and that's amazing because before I had dbg, for example, let's see what I have inside person at this point. So I was going to come here and do a println and try to get the print or the debug for person, and then the same thing. Person cannot be formatted. Okay, person. This should be with the debug template. Yeah. And then, okay, I can see now that I have the object created. I have no problems. I can inspect it depending on how complex is my expression here. But recently we got dbg, and then we can just remove this print, and we can pass dbg here in the proper object. So that's amazing, because I can have dbg in lots of parts of my code during development. I can just run it. The return of the dbg, I can, okay, I'm not using, it's just a warning, yeah, but you see the dbg is here. This warning say that I'm not using person. So if I want to have an used variable, I can put underscore here and just hit run again. And look how interesting it. dbg is a macro that's going to take the instance of this struct, this person struct. It's going to return the value to my variable, yeah, where I want to attribute it, but it's going also to display a message in my debugger. So now I have something like a logger, yeah. I can see here that I created a person name, and I see the type, I see the structure, so I can wrap any expression around dbg and it's going to be logged. So it works like a debugger or a logger. And after I finish my development, I can just remove all the dbgs. I don't remember right now the actual thing, but there's a cargo stuff that cleans all the dbg for us. And actually we can also leave all the dbgs there because when we compile with -- release, the dbg is going to be ignored, yeah. So in our final compiled code, the dbg is not going to be there. Lemirador, thanks for following. What are other macros that may be useful for us in the day-to-day? I was thinking about print, dbg, that also, okay, there's another one. Another one is, let's say I have multiple person. What I can do with multiple person, for example, is to create a vector. So I can came here and say that people equals a vector of person, yeah. And this vector of person, people, no, I'm doing wrong. People, a vector of person is equal of a new vector, right? So something like this. So let's say I want to create a vector, yeah, a list with lots of instance of person inside it. Generally what I would do is I would create an empty vector like this, people equal vac new. And then I would do this as a mutable, and I would start doing like people dot, I think it's push, and then I will start pushing people inside it. If I remember correctly, that's what we can do. Let me put another person here like this. Oh, I misspelled the name. Let me see if the compiler is going to okay, that's compiled, so that's okay. So I created a list, a vector with two people, two instances of person inside it. So that's the way we can do it. Another way is using the vac macro, yeah. So we can have the vac macro and do, for example, let people equals vac, and then we can pass the things that we want to push to that vector like this. So this macro is just like a syntax sugar to the those 3 lines we did before. We can just use this if I okay, it's just a warning that I'm not using. I always forget about putting the underscore there. Okay, and that's it. So if I call dbg right now, I can have dbg for people, and I can also have dbg for the underscore people, which now are totally different variables. But that's it. So this is the same thing, and we use it 2 ways of creating it, and this is also another macro that's very useful. So you can take the idea of how and why we are going to use macros during our Rust development. In macros, macro is short for macro instruction, blah blah blah. And let's go to the problem statement. So what we want to be implementing today. You can produce a vector of arbitrary length inline by using Vac Macro. So I have already showed this to you, right? We just played with it here. We have a vector of people here. It's the common way to do that. You need to create the macro using this creating the new thing, and then you just pass you can create using just vector passing the instances of and the objects you want to put inside the macro. So this usually is the way people does because it's easier. And thank you for following Tutor Exilius. And okay, however, Rust doesn't come with a way to produce a hash map inline. Oh, that's really something that I missed when I started playing with Rust. Because in Python, we are used to do, let me remove all this code here. In Python, for example, we are used to do like data equal, and then we just start a dictionary and we put key and value, right? So this is the way we create dictionaries in Python. That's easy, but Rust doesn't come with this kind of stuff. Yeah, so if we want to have something like a dictionary in Rust, we need to use the hash map that we have used in the other exercises. But first we need to create a hash map, and then we need to start including people data into the dictionary. And this dictionary, obviously, we need to create it saying what is the type of the key and what is the type of the value. Yeah, so, and I know there are some crates available for us to have a hash map macro, and I think this is what we are going to implement right now. So, well, I rectify this by reading a hash map macro. So for example, a user of your library might write hash map and pass the values using arrows, and this value should expand to this hash map new, like I was showing before. And we are doing hash map insert, and Rust is going to know what's the type of key and value by this first time we insert. It's going to infer by this. And yeah, so note that maplet crate provides a macro which perfectly solves this. Please implement your own solution, yeah, instead of using this crate. Okay, let's go. So I will open here. I think I already have it open, so I'll take this moment to give my thanks for everyone who is supporting this channel. So we have this list of people here who is on our financial campaign and are supporting the channel. So if you want to support the channel, you can see the links here on the panels, and you can also subscribe if you like it. Yeah, we are still learning Rust, but we have plans to create awesome projects here. Yeah, so I will just get the exercise locally, and I can do this by copying this and pasting here. Cool. And let's go to the macros and open the VS Code. Let me see how many CPU I have free before I do that. Yeah, I think I have enough CPU to open VS Code. And I saw someone asked about VS Code here before. I don't remember if it was Leo or someone else. Someone asked about my VS Code environment, right? It was Leo. I have a problem with IDE hints and completions when using macros. How is it for VS Code? Yeah. So let's see. I don't remember actually. One thing to note is that now I'm using Rust Analyzer. Yeah, so there are two main extensions for Rust. One of them is RLS. If you watched my YouTube videos where I talk about Rust extensions for VS Code, on that video I was showing RLS extension, how to install it, and what which features it brings. But I started using Rust Analyzer, and I think it's nice. Yeah, it's working okay. It took me a time to get used to it. And looks like Rust Analyzer is going to be the default recommended thing. I was reading some article today. I think there's an RFC or something to make it the default. Yeah, so it looks like it's more powerful because it can bring powerful hints on the code. So I don't know. We are going to see, I think, native RLS, native Rust Analyzer is going to autocomplete the arguments for a macro. I might be wrong about that, not sure, but I think it's not easy to generate autocompletion for macros. Yeah, maybe there's a way, but I think for most macros it's not that easy. But let's see that. Maybe it's possible and I'm wrong. Let's start by looking the test cases. Okay, so we have this macros, RS, and what it's doing here. So our goal is to create a hash map, inline hash map. So it's creating a testing empty. So expected is a hash map with U32 using the hash map new. And we need to provide the same thing if we have a call for hash map, which is empty. So that means inside our macro, we also need to consider empty. Yeah, so when we don't have any matches, we need to consider that case. So, okay. We have the test single. So in these two lines here, we create a hash map and we insert one as key and one string as value. And using the hash map macro, we can use this arrow syntax to create the same thing. Okay, no trailing comma. So we need to consider a trailing comma. Oh, that's now it's starting to get more difficult. Yeah, I think that details is going to be tricky, I think. So here the same thing, we insert two things, but our macro doesn't have the trailing comma. And here we do the same, but we have the trailing comma. Oh, that's because the Rust FMT, the formatter, is going to include the trailing comma for us depending on the configuration. So that's why we need to consider that. Yeah. Test nested. That's interesting. If we have nested hash maps, we need also to consider that. So maybe, I don't know if it's important to have some recursive call. Started to, I was very comfortable with this exercise, but now I'm starting to get more afraid of it because of those details. Yeah. And then we have compile fail. Yeah. And then we are going to assert the negative case. So we have this comma sap rs, and I think there is some invalidity test cases here, and these are something that we expect to fail. So we write test invalid. Here they call invalid, but usually I see people calling positive and negative test cases, and these are something that are not possible to create, and we need to ensure our macro is also strict at this point. Okay, and let's go to the code. Right. So let's get started by opening our shell and running cargo test. I will not include ignore at this first run, and we have build failing because of the unimplemented, right? No rules expected, blah blah blah. Okay, and no rules. Okay, so our macro already exists here, so we create a macro like this. We put macro rules, put the name of the macro. There is another test case at the end, Nathaniel is saying. Let me see. At the end of the same file. Let me go there. Oh, there's a very huge test case here. Which is this? There is the nested, and looks like I changed something here. Yeah, so okay. I think this is just the thing that's going to try to fail, right? Test compile fail to arrows after all the fail to compile test cases. Okay, so this is the fail to compile. Then we have a model, and we have used macros type not in scope. Yeah, this one, type not in scope. Okay, I got it. When we don't have hash map in our scope, we need we are going to call it, and what we expect here. Expected is standard collections hash map. It's going to return an empty hash map. It's not empty. Yeah, so it's just, I don't even know how to call this type here. It's a hash map of two empty unit types. Yeah, that the test case compiles. Okay, so the test case itself is going to compile, but if it runs, the hash map is not going to be in the scope, right? Okay. And here it's just the compile fail function. What's the compile fail function using? It's using some new cargo current. It's interesting. It's running cargo in a sub process, right? That's nice. How is it doing this? It's using process command, and inside the process command, it's running cargo again with that file name we passed That's cool. That's a very nice, very good snippet. I can copy and maybe reuse for something else. Yeah, cool. Okay, so let's start by the first test case, right? The first test case is the test empty. So I expect to create a hash map new. And if I call it without passing anything, I just need to return. Okay, so I think I'll need to try to capture the empty thing first. I'll need to go to the macros by example. And there's a place here on the macros by example where I can find all the rules, all the patterns. Let me find, yeah, this is what I was looking for. This is the meta variables. This is all the kinds of patterns that I can use to catch on my macro. I was already talking about I10 block, identifier, path, token tree. Here, token tree, a single token matching delimiters. This is interesting. Maybe it's something that I can use. I don't know. Meta lifetime visibility qualifier. Okay, visibility, I think it's going to catch pub and that kind of thing, qualifiers. Literal matches, literal expression, okay. Then we have repetitions. I think we want to have repetitions, yeah? But not for this first test case. For the test case, for example, this, we have two things being passed to the hash map. We have identifier or express. I think it's an expression, but we are going to see. So in this expression here, we have 1, 2, and this is limitless. People using HashMap can pass multiple things, and we want to capture everything separated by commas. And I think to do that, we are going to use repetitions, and it's going to be like this. I think exactly like this, but we need to consider the commas. I don't know, but I think it's going to be a lot of try and errors. Scoping. What I'm looking for here is how do I match empty test case, right? So if I call HashMap without passing anything, maybe it's just like in a pattern match where I can use underscore as a catch-all. Yeah, I'll try that. If I'm wrong, I'll learn it by code, yeah? So what it's doing here is unimplemented. Let me see. The only test that is running is this one, right? The others are ignored. Yeah, that worked. So I need to make it compile, but now I'm able to make the first test case to pass. Okay, so the first test passed, and that's cool. That's very easy. If I call the macro without passing anything, it's going to return an empty hash map. Then what I'm going to do is I'm going to uncomment one by one, so I will not be taking care if others are going to compile or not. Yeah, I think it's going to be easier. So now I need to test a single value. And now, maybe when I solve this one, I will solve most of the other ones, except that the others are more difficult because of the trailing thing, the trailing comma. Okay, but let's go with this test single. So looks like now I need to put another pattern here, just behind that, just below that. And in this pattern, I want to capture, let me comment here. What I want to capture is when people call it like this and pass one arrow and a value like anything. I don't care about commas and multiple values yet. I care about getting a single thing for that test case. This pattern matches with which meta values of the macros by example. So for example, an item. What's an item? I think an item is something from an iterator. Is that the same? Okay, no. Item here is a different thing. So models, crates, use declarations, functions. Okay, not what I want. I think what I want is identifier. Yeah, maybe. Because not identifier. Yeah, I'm not. If I was going to use just names, maybe. But here I have an integer. It's a primitive type, but I can also have other kinds of types being keys or values. So it's more generic stuff. It's not identifiers. What is that? A pattern. Let me see what is a pattern. Literal pattern, wildcard, range, struct, type. If you let, okay, this is a pattern. Patterns, okay, patterns are used in match, so I can capture a pattern in the macro argument. That's cool. But that's not what I like. What I need. I know that I can try to get as expression, but the problem of getting this as expression is that maybe I'll need to parse the expression, because the expression is going to be the whole thing, right? All of this is an expression. Or do I have an expression here and an expression here? Or I can use this as, I can use the arrow stuff. I can use the arrow as the actual separator for the, yeah, maybe. So let's try. So what I'm going to capture here is a key and a value. So I'm going to have a key. I'll name like this. Yeah, so this is how we name variables that are going to be captured. And the type of this meta variable is going to be expression. And this expression is going to be followed by the arrow. And then I'm going to have my value, which is also going to be another expression. Yeah. Why I don't use, I don't have a meta value, I think, to get all the primitive types, for example. Item block statement. Without the trailing same column, except for item statements that require same column. It's not an statement. Type F token tree, lifetime. Yeah, I think it's an expression. because anything is an expression. If I go to a Rust, I can try this like here. I have this AVCR thing. Yeah, so this is like an IPython for Rust. It's a wrapper. If I just do 1 followed by a semicolon, well, my Unicode is not working. I think my terminal is playing with me. Let me try different stuff. I need to go to the bash first, and then I call avcxr IDE mode, and then I think I'm not going to have the same problem. Oh, I have, but now I have the output, so that's better. So look, I just do 1 and it returns me 1, so it's an expression, right? So if I do 2, it's an expression. If I do hello, it gets me hello back. If I do, for example, struct, it's going to fail because struct is not an expression. Struct is something that I would be getting, I think, as a type. Yeah, so if there is a meta variable for a type, like here we have type, I would get this using that meta variable. So in my case, I'm doing this and, for example, this. Okay, so the whole stuff is not a valid expression, but if I do the key and value separately, each of them are expression. And as I'm using this arrow in the macro as a hard-coded separator there, I think it's going to be result. In this case, it's going to be this. Yeah, that's what I think. And then this pattern, now I'm in the proper pattern match stuff. I'm going to return the block that is going to create my hash map. Cool. So now I'm going to create my hash map inside here. It needs to be mutable. I'm going to create my hash map here the same way I did on the playground before. And then I'm going to take that single value. I'm not taking care of the repetitions yet. I'll take care later, but right now I'm just making that specific test to pass. Oh, I need to give a name to this. So let mut my new hash map. So it's going to be nh new hash map. New hash map. No, not good. I'll call it hash. I'll call it map. So let mut map equal. Oh no, I'm a Python developer. I'll call it dict. Yeah, so it's clear that it's just like a Python dictionary. Okay, so I have my dictionary, and then I will do dict dot insert, and I will take the value of key and the value of val, and that's it. I create it, and at the end I return the dict. Right, so if someone passes an expression followed by arrow, I don't know if I have to deal with spaces. Yeah, so if someone passes like this, but I think it's automatic. It's going to be catched by Rust itself. Okay, so an expression here, arrow, expression here, then the block here is going to be. If I just put those 2 lines here, it's going to fail. But if I embrace it in a new scope, yeah, so for example, if I get these 2 lines and just copy and paste here, I'm going to have error because this is invalid syntax. But if I put this inside a new scope, I can put the things in this new scope and just return something here. So that's what the macro is expanding right now. Yeah. Okay. Tricky. I knew that. I knew that this exercise is going to be having those tricky things. Yeah. Okay. Now I have that test passing. Cool. Let's go to the next. No trailing comma, but now I have two expressions to match, right? And it's going to fail, obviously, because there is no rule for a comma. First way to do that, in both the matcher and the transcriber. Just as recap, matcher is this part here, right? Which are between the parentheses, is the thing that we are going to capture when someone calls our macro, yeah? And this is our matcher. The transcriber is the code block that we are transcribing and expanding the code. And in our case, this is all the code that's going to be expanded. Here, instead of doing two inserts, I want to repeat this insert here. And I can do that, I think, using... I think I can, for example, have any kind of loops here, maybe. Can do, but I need to capture this as repetition. Yeah, so if it was regular expressions, I don't know if it follows the same as regular expression. But for example, if it was regular expression, I would put an asterisk here. Yeah, so I have this pattern, and it can repeat multiple times. In regular expression, it's an asterisk. And here, for repetitions, looks like it must come inside a block followed by a $sign. So we have to put our pattern inside it because our pattern can repeat. That's what I'm... let me see. So for instance, this, if I capture y ident followed by a comma and an asterisk, represents any number of identifiers separated by comma. So this is exactly what we need. We need this, but we are not using ident, we're using expression. So looking at this, for me, looks like I was almost right. I just need to put here a comma, and all this block, instead of having only parentheses, should have a $sign here. But I think a $sign at the first level is going to give me error. So I imagine it that I can have this pattern repeated many times followed by a comma. Let me see if it even compile. No rules for this token in the macro call. Okay, so I was expecting this error because I know that this pattern should be in parentheses like this one. So maybe I need extra parentheses here following all my pattern. If I was with the rainbow brackets here, it was going to be easy. I have uninstalled because I was thinking that rainbow brackets was using all my CPU, and I removed most of my VS Code extensions. But these are, I put a little bit of space here. So okay, these are the main pattern. Then inside here, I will take this expression, and this can repeat multiple times because of the asterisk. And then inside here, how can I capture this if it's not going to be a single key and a value anymore? I need to do a loop. I don't think I can do a simple loop. Now I have to get back here. So asterisk indicates any number of repetitions. So looks like it works like a regular expression. Indicates a number, but at least one. No, because we can have empty and question mark. But I remember about that word being used. So I think something like this. Oh, no, because I need multiple semicolons. So this is what I want to be repeating. And now I will put an asterisk here. Whoa. Let me see. Wow, it compiled. Cool. Okay, so we have 3 tests passing. This one was tricky. Yeah. And I don't think it's beautiful. Yeah, the syntax is not very, very beautiful. But it works. Let me remove these white spaces here. And let's have another test case. Let me remove the ignore. Okay, so test trailing comma. Now it's interesting. We can have now a trailing comma. Wesley 12K. What is this? Hi Wesley, welcome to the Code Show. This is a test case written in Rust. We need now to create this HashMap macro. And we need to ensure that this macro accepts a key and a value, but also accepts a trailing comma. If it's a regular expression-ish thing, it's something like a regular expression. And here I have this asterisk, meaning multiple repetitions. And I want to have a comma here as optional. I remember that on the macros by example, we have a rule. I was looking here. Here, question mark indicates an optional fragment with 0 or no or 1 occurrences, okay? 0 or 1. What if I put question mark asterisk? It's going to be 0 or 1 or many. But anyway, in our case, we just want a single one at the end. So I think it's going to be another comma and a question mark. Maybe. Yeah, makes sense. If I was, but in the regular expression, I would need to separate the groups. But here I have first thing, I can have a comma and it's optional. Let me try like this before I try to put a different separator there. Doesn't work. Okay, when I see this error is missing tokens in macro argument. Okay, so in this case, this comma is not optional. It's required. I need to make it optional. So maybe I need to get this in a group like in a regular expression. And this group maybe should be using the same rule as this first group. $, a group, then I have it followed by a comma multiple times, then this is going to be another group, and this another group is going to have a comma, and this comma is can happen optionally. Let me see. Not yet. Expected one of asterisk plus or okay. It says what it expected but doesn't say what it found. But maybe the question mark should go out of this group. So I have this group and a question mark. Cool. Cargo test. Oh, that's it. Awesome. Tests are passing. That's interesting. So this is really like an irregular expression. We use this $, sign to separate the groups, and these are the quantificators of this thing.